Hey, my fellow stargazing connoisseurs. Have you ever wondered how the great old sun came into being? Well, grab a snack and let me spin you the tale of our favorite cosmic diva's origins. Once upon a time, there was a cloud, a big, gassy, dusty cloud, not to be confused with the ones that rudely ruin your springtime picnics. But this cloud was so dense it started collapsing under its own weight. Anyway, as this happened, all the gas and dust decided to hang out in these tight little pockets, cozy like the pants you never want to admit are too small. But these pockets started spinning faster than you can say galactic whirlpool. They turned into a big old ball, and while this ball was busy doing its thing, the leftover dust decided to flatten itself into a disc, like the skinny legend it was. Now, let's step back over 4.5 billion years to a time when the sun was just a young protostar in its cosmic nursery. For about 10,000 years, it underwent a rapid transformation. Then, with the ignition of nuclear fusion in its core, the sun became the powerful and enduring star that we orbit today. At this stage, it's what's called a T-Tauri star. Fancy name, right? Basically, it's a star equivalent of a toddler throwing a tantrum in a grocery store. The T-Tauri stars are known for spewing ridiculous amounts of solar wind, just like your little ray of sunshine is for spewing spit, I suppose. Oh, and remember that flat disk we talked about earlier? This very disk goes on to create the planets, asteroids, and eventually you. Guess you're a star after all. Part of one, anyways. Next, the sun's journey into its main sequence begins with nuclear fusion in its core. Here, hydrogen fuses into helium, unleashing immense energy, radiation, and neutrinos, a process that powers the sun's brilliance. During this stage, the sun becomes a star in its prime, burning through hydrogen fuel at an incredible rate, turning about 600 million tons of matter into energy every second. But even stars have limits. One day, billions of years from now, our sun's fuel will run out. For now, though, it's still glowing strong, lighting our days, and powering life on Earth. Following this, it becomes a red giant? What would that mean? Well, just like your grandmother gets older and older, so does the sun. For the sun, this just means it is and will lose fuel, begin to swell, and turn red. It also gets hungry and will eat 3 of the first planets in the solar system. The core will burn so hot, it's enough to burn helium into carbon. And just like an onion will shed its outer layers exposing its core, this will happen 5.4 billion years later from now. This leads us to, the final stage. What a journey we've endured. The white dwarf, which will be 5.5 billion trillion years from now. The red giant has now become a planetary nebula that cools down over roughly 1,000 years. Only the core of the star will be left behind. Though no nuclear fusion will happen during this, its brightness will eventually fade to black, concluding the life of our star.